In today's class, we shall learn about design of synchronous counters. But before that, we should understand what is asynchronous counter. Now, in the past three classes, we have learned about asynchronous counters. Now, what is the basic difference? The basic difference is in case of asynchronous counters, the clock is not simultaneous, right? This was the design, if you can recall. The Q0 of the first flip-flop was acting as clock to the second flip-flop, and the output of the first flip-flop or second flip-flop was acting as the clock of the third flip-flop, right? So this is the basic of asynchronous counter design, right? We were utilizing the property of negative edge triggered flip-flops, where the flip-flops used to toggle at the negative edges of the clock pulse. Now what is synchronous counters? Let us understand what is synchronous counter. Right. Now uh, in case of synchronous counters, all the clocks are given simultaneously. All the clocks are given simultaneously, right? This is the basic difference, that in case of synchronous counter, all the clocks are given from a single clock, while in case of asynchronous counter, the main clock is given to the first flip-flop, output of first flip-flop to the second, and then onwards. What is the advantage of synchronous counter? The disadvantage of asynchronous counter is the advantage of synchronous counter. What was the disadvantage of asynchronous counter? In case of asynchronous counter, there was delay. This clock, this clock was having its own timing of negative edges, but in that negative edge, the output was not subsequently changing. It was taking some time, and that time is the delay of this flip-flop. Why? Because flip-flop contains NAND gates or any other logical gate, and those gates are made of basically transistors, and in case of every transistor there is a time delay, and that time delay percolates in the whole device, that is the flip-flop, and we have a delay time. That delay time is known as propagation delay. So with the advancement of this clock pulse, the outputs of this Q0, Q1, Q2 will change, but with a delay. So the clocking time will also be different. The clocking will also be different, right? The clocking will also be different. Due to this delay, the output will always be slow with respect to the input clock. Now that is what is not wanted, right? What we want, that whenever the clock comes, that is we are giving the clock, right? So what we want, whenever we give the clock or whenever we give the command, at that very moment the output should change. There should not be any delay. So for that we have designed synchronous counters. What we can see, all the flip-flops are getting clocked simultaneously, so that the output of these flip-flops can change simultaneously, right? Simultaneously means at the same time. That is, the very time the clock appears, the output is going to change. Now today we shall learn about the design of mod 5 synchronous counter. Now can you recall how to get the number of flip-flops required for a particular counter? What was the formula? Yes, the formula was that 2 to the power n should be greater than number of count. 2 to the power n should be greater than number of count. Now what we are designing mod 5 counter, so the number, the n should be what? N should be 3. So what is n? N is the number of flip-flop, alright? So the number of flip-flops will be 3, and as such with 3 flip-flops we get 3 input outputs. Let us see, right? See, we have 3 input outputs for 3 flip-flops. Suppose for one flip-flop, the input is J0 K0 and the output is Q0. Similarly, for the second one it will be J1 K1 Q1, and the third one it will be J2 K2 Q2. Now let us make the table for it. We are writing what? Present state, right? We are writing present state. Fine. Next we are writing what? Next state, and then J0 J2 K2 J1 K1 J0 K0, right? So this is it. This is what we are doing. Present state, next state, J2 K2 J1 K1 J0 K0. Now for present state we have 3 flip-flops, and that is why it would be what? Q2 Q1 Q0. In case of next state it will be again Q2 Q1 Q0, and likewise. So what are the outputs? How would we like the output to change? We like to start from 0, then 1, then 2, then 3, then 4, then 5. No, not 5. Why? Because this is a mod 5 counter. After 4 it should get down to what? 0, right? So that is what we are writing. So what is 0? In terms of Q2, Q1, Q0 it should be what? 0, 0, 0, right? What is 0? It is 0, 0, 0. Fine? It is 0, 0, 0, right? Okay. And what is 1? What is 1? 1 is 0, 0, 1. What is 2? 0, 1, 0. What is 3? 0, 1, 1. What is 4? 1, 0, 0. And what is 0? 0, 0, 0 again. Right? Okay. Now what is the next state of 0, 0, 0? The next state of 0, 0, 0 is 0, 0, 1. So what we are doing? We are writing 0, 0, 1 here. So it is indicating that this is the present state and this is the next state. Similarly, from 0, 0, 1 it should be what? 0, 1, 0. From 0, 1, 0 it should be what? 0, 1, 1. From 0, 1, 1 it should be what? 1, 0, 0. And from 1, 0, 0 it should be what? It is 0, 0, 0. So this is how it is changing, right? So if the output changes from 0 to 0, the output changes from 0 to 0. Whose out? Q2 output. See, Q2 output is changing from 0 to 0. So if it changes from 0 to 0, we can write what? J0, J2 0 and K2 don't care. If Q2 changes from 0 to 0, then what we can write? What are the values, possible values of J2 K2? It is J0, K don't care. And where from we get it? We get it from the excitation table, right? Then Q1 changing from 0 to 0 again. So J0, K don't care. And Q0 changes from 0 to 1. So it will be J1, K don't care. Now let's talk about again 0 to 0. So 0 don't care. Then 0 to 1, then 1 don't care. Then 1 to 0. Now if it changes from 1 to 0, then it will be don't care 1, right? Again 0 to 0, 0 don't care. Then 1 to 1, don't care 0, 0 to 1, 1 don't care. Next 0 to 1, 1 don't care. Next 1 to 0 don't care 1. Then 1 to 0 it's don't care 1. Then 1 to 0 it's don't care 1. Then 0 to 0, 0 don't care. 0 to 0, 0 don't care. So this is what it is. This is what we are getting, the input that we are getting from the concept of the excitation table. Now what shall we be doing? We shall be drawing the J2, J1, J0, right? The K maps of J2, J1, J0. Fine. Now how many variables are there? 5. So 8 cell flip-flop will be sufficient, right? For J1 also we are drawing it. Fine. From J0 also we are drawing it. Fine. Right. Similarly for K2, K1, K0. So for K2 we are drawing it. For K1 we are also drawing it. From K0 we are also drawing it. Right? And also what about the inputs? Q2 bar, Q1 bar, Q2 bar, Q1, Q2, Q1, Q2, Q1 bar. And this would be what? Q0 bar, Q0. Fine. Now let us write the inputs. It is 0, 0, 0, 1, don't care. So we should write 0, 0, 0, 1, don't care. Right? Similarly, what about J1? 0, 1, don't care, 0. So it should be 0, 1, don't care, 0. Now what is J0? 1 don't care, 1 don't care, 0. So it should be 1 don't care, 1 don't care, 0. Now what is K2? K2 is don't care, don't care, 1. What is K1? K1 is don't care, 0, 1, don't care. And what about K0? Don't care 1, don't care 1, don't care. And the rest cells will be, of course, don't care, because we do not know what they are. So in that case we should put don't cares. Now let us proceed to the design. See, here we can get a pair, right? The output of the pair would be Q1, Q0, Q0 and Q1, right? What about this? This would be this only, that is Q0. What about this? This would be this only, and this is what? Q2 bar, right? Q2 bar, common is Q2 bar. These variables are same for all the k-maps, right? Fine. And what about K2? K2 is always 1, see? And what about K1? K1 is Q0 again. And what about K0? K0 is 1. Right. So let us design J0, K0, Q0, J1, K1, Q1, J2, K2, Q2. Now what we are doing, we are giving them clock simultaneously, because that is the condition of synchronous counter, right? Now what is the value of J0? What is the value of J0? It is Q2 bar. So what we are doing, we are taking from Q2 bar and we are giving it to J0, right? So what is the value of K0? It is 1. K0 is 1. And what is the value of K2? K2 is also 1, right? So we are putting voltage here. What is the value of J1? J1 is Q0, K1 is also Q0. See, J1, K1 both are Q0, so we are giving them Q0. And what is J2? J2 is Q1, Q0. So take Q1 and Q0 and give them AND gate. Right? So this is the design. This is the design of mod 5 counter. So this becomes mod 5 counter. Right? Now how can we be sure that we have designed rightly or not? Right? So for that we should check for the lockout. Right? We should check for the lockout, and for the lockout what we are doing, we are going here and we are writing J0, K0, Q0, J1, K1, Q1, J2, K2, Q2, right? All the inputs and outputs that we are writing. Fine. Now, how to check lockout? Check the last state, right? Now, last state is what? Last state is this one. This is the last state. 4. 4 is the last state. After 4 it should become 0, 0, 0. 4 means 1, 0, 0, right? So we take 4, that is 1, 0, 0. So this is what? 1, 0, 0. Now this is 1, this is 0, and this is 0. Right? So this is given. What we need to determine? What will be the next state? Fine. Now what is J0? What is J0? What is the formula for J0? Formula for J0 is what? Formula for J0 is Q2 bar, right? According to design, J0 is Q2 bar. So what we are doing here? Q2 is 1, right? Q2 is what? 1, 1, 0, 0. So Q2 is 1, right? So what we are doing? What will be Q2 bar? If Q2 is 1, Q2 bar will be 0. So here J0 will be 0. What about K0? What about K0? K0 will be what? K0 will be 1 because it is connected to class VCC. So K0 will be 1. So what about J1? J1 is Q0, right? See, what is this? This is J1 is Q0, K1 is also Q0. So that is what we are doing. We are giving Q0, right? And what about Q0 is 0, so these two also become 0. What about J2? J2 is the end of Q1 and Q0. Both are 0. So obviously J2 will be 0. And what about K2? K2 is 1, right? According to the design, this design, K2 is 1. See. According to the design, K2 is 1. Right. Now we get to the next step. And what will be the next step? The next step will be, if it is 0, 1, then output follows J, then this should be 0, right? And if it is 0, 0, then no change. So the state will be written. And if it is 0, 1, then output follows J. So this should be 0, right? So Q2, Q1, Q0 would be 0, 0, 0. So this is it. After 4 it is becoming 0. So this is known as check for lockout, right? So whether we are locking out the other possible counting states or not, right? So this is how we design a synchronous counter, and this is how we proceed, right? Thank you.